So we're going to look at points, lines, and planes, and we're going to look at labeling these as well as drawing these. So just as a reminder from our vocabulary, a point has neither size nor shape, right? It's that zero-dimensional object. A line, there's exactly one line through any 2 points. A plane, there's exactly one plane through any 3 non-collinear points. That's the key, so they can't all be on the same line. Collinear, points on the same line. And coplanar, points that are in the same plane. Okay, so we want to be labeling these guys. So a line containing point P, and we want to name that. And we want to name it in a couple of different ways. So this line can be named as line, and then we have this special little letter out here. It's lowercase and it's at the end and it's not attached to the point. So we can call this line N if we would like. Okay, we can also name this line by using any 2 points on this line, and we can have those in any order, right? So we can name this PQ with the little line notation above it, QR, or remember, we could simply switch them, RQ. Those are all naming the same line. Okay. So now we want to name a plane containing point Q. So we could name this as plane B, right? Using that special little letter in the corner that's not attached to a point. Or we could name this plane using any 3 points. Now, because when we're naming a plane, we don't have any sort of special notation, we do need to write that word in front of our 3 letters. So plane and then pick any 3 letters, any 3 points. But they do have to be any 3, ooh, why did I write 3 there? This should be non-collinear. Non-collinear points. That's the important part, right? So we do not want to name this PQR because those are on the same line. So we want to avoid those 3 letters together, and we're going to use this M out here to help us do that. So this could be plain PQM, RQM, or say MQP. So any 3 points as long as they're not on the same line. So we want to take a look at constructing some things and naming some things. So real quick, let's just kind of name some items on this figure to the right. Take a moment, pause the video, try to do it yourself, and then check your answers against mine. And yours might be slightly different. So that line containing point A could be named in 3 different ways, line N, or we could use AB or BA with the notation. A plane containing point D could be named in a couple of different ways, plane ABD, and those letters could be in any order, or plane Q. So let's try drawing. Whenever you're constructing or drawing, I always suggest kind of start with one figure and build off of it. So it says plane R. All right, so we know we have a plane R. So I'm just going to draw real quick a plane. And planes are typically drawn as sort of these off-kilter rectangles. And it says it's plane R, so I'm going to label that and put an R on the side. All right, it contains line AB and line DE, which intersect at point P. So I have 2 lines and they're intersecting. So let's draw. So these lines are on this plane contained in. So this is AB, so we need to label it A, B, and then DE intersects it. So let's draw DE. And then it says they intersect at P, so I need to find their intersection point and label that. So that first part is done. Now we want to do the second point. Add point C on plane R. so that it is not collinear with AB or DE. Okay, so it can't be on those either two lines. It has to be basically anywhere else. So out here, we're going to put a point C, and now we have done that. So let's take a look at segment bisectors. So just a reminder, a segment bisector is a line, array, or a segment which cuts a line segment into two congruent segments. Okay, cuts a segment into two congruent segments. So here in this figure, we're really looking at segment. I'm going to make this a little bit bigger so we can look at it. We're really looking at this segment EF or EG here. So we're looking at this segment EG. It is on a line, but this is a segment. So this is our segment. And this line here, line N, this is our segment bisector. Okay, so we said this segment bisector, right? It intersects our segment at the midpoint. And it cuts our segment into two congruent pieces. So we have two congruent pieces here, EF and FG. And we label on the figure that they're congruent by these little tick marks, right? Each segment has one tick mark. Any segment with one tick mark is congruent to all other segments with one tick mark. Okay, so we're going to use this to answer some questions. Name two congruent segments. Well, we can look on there and we can say, all right, anything with one tick mark is congruent. So that's segment EF and segment FG are congruent because line N is a segment bisector. So we know they're congruent because N cut that original segment into two congruent parts. All right, let's just try a couple more things. So this says draw ray, so it has a little ray symbol, AB, bisecting segment XY at point Q. So we're going to have a ray and a segment. They're going to intersect, but specifically they're going to bisect at point Q. So remember, the thing being cut in half is always going to be a segment. So this guy right here, the second one in the sentence, that is what's getting cut in half. So let's put that down first. All right, X, Y. Now, whenever I have something being bisected, I like to just, as a placeholder, kind of say, all right, well, any bisecting happens in the middle, right? Always happens at the midpoint. So let's just stick that midpoint on there. All right, now it's being bisected by a ray. So I know I'm going to have a ray going through that midpoint. Okay, not a great drawn ray. Now, if you look at the name of the ray, remember the first letter is always the end point, and the second letter is always some point on the ray. So we're going to name this A, and then somewhere down the line on the ray is going to be B. And it says it's bisecting it at point Q. So this midpoint, right, the point of intersection or of bisection is point Q. And there's our figure. Okay. Last thing we're going to look at drawing is perpendicular lines. So perpendicular lines are any two lines, so reminder from definition, that intersect at a right angle, which remember is 90 degrees. So we want to draw and label a set of perpendicular lines. We already have one. All right, and I'll label it because it asks me to label. So I'm going to name this AB. I'm going to put 2 points on it. This is going to be line AB. Now I know what perpendicular looks like, right? Here's a perpendicular line. And it looks like a perpendicular line, but in geometry, nothing is what it looks like unless I put something on the figure to tell you that it's true. So currently nothing on the figure is telling me that these are perpendicular. They just look like it. So I have to add that little box in the corner there, and now I know they are perpendicular.